Hey everybody, welcome back. Today we're going to continue lesson 2 in chapter 3, and this lesson focuses on, or at least the second part of the lesson focuses on, how do we determine if a domain is discrete or continuous. Now these are words you might have heard just in regular everyday life, but as they relate to math, discrete data or discrete domains are domains that only have certain specific numbers that are allowed, and usually that means there are no decimals, right? It has to be only whole numbers. Think of situations where you cannot have a fractional amount of something. You can't have a decimal amount. Like when I go order new soccer uniforms for the soccer team, or football jerseys for the football team, or volleyball shorts for the volleyball girls. I can't order a half of a jersey, or I can't order 3/8 of a pair of shorts, or 2.75 uniforms. If I'm getting shoulder pads, I can't buy 2 1/2 shoulder pads. And so situations where decimals are impossible and fractional amounts are impossible, we're going to call that discrete data, and those will have discrete domains. The other example would be continuous, and continuous domains or continuous data is where it is okay and it is allowable to have any type of fraction, decimal, whole number. There is a range of numbers where every single number in between something and something is going to be acceptable. For example, the number of hours you work at your job, right? You could work 8 2/3 hours. You could work 3.5 hours. You could work 5.7 hours. Anytime where you can have a decimal or a fractional amount, and it's possible in this situation to have a fraction or a decimal, you're going to go ahead and call that continuous. So how will these graphs look? Down here at the bottom, I have a couple examples. The discrete are very obvious. They will always be separate dots. They are not connected. So like if this was labeled down at the bottom 1, 2, 3, 4, 5, and obviously I could label it going up here. If I asked you to describe the domain of this, I would say, okay, this is a discrete domain, and then the domain is only going to be, just like we saw in the video the other day, is only going to be these specific numbers. The domain is going to be 0, 1, 2, 3, 4, and 5. Sorry, I ran out of room there. Okay. So whenever it asks you what is the domain and it's a discrete situation, it's only those specific numbers. Only those specific x coordinates, right? If it is a situation like this, where obviously this is 0, and then maybe it goes 1, 2, 3, 4, 5. If it's a continuous situation, the graph is going to have a line segment, right? It's going to be connected between 2 points. And so that it is very obvious to tell which is which. Discrete is just going to be dots. Unconnected, separate dots. Continuous is going to have a line segment. And if I ask you, hey, what is the domain of this one? You would say, okay, the domain is, it's not just the numbers 1, 2, 3, 4, and 5. It's everything from 0 to 5, all the numbers in between. That's why it's connected. And so in this situation, actually, I don't want to write it like that. I made a mistake. Actually, you want to write it like this. All the numbers between 0, on the x-axis between 0 and 5. Remember to put the less than symbol. How do I know whether to do the less than or equal to, or just the regular less than? Look at the circles, right? If it's a closed circle like this, you're going to have the equal to bar underneath it. If these would have been open circles, like maybe like that and like this, then you would have no equal to bar underneath it. And that kind of fooled a few people on the last assignment, and that was my fault. Like if only one of them was filled in, then you would have put the underline underneath that number. Like if the dot on the 5 is colored in, you would put the underline on the 5. So that's how you can tell if a graph is discrete or continuous. If it's all separate dots, it's going to be discrete, and whenever you list the domain, you just list the numbers, 0, 1, 2, 3, 4, 5, whatever these x coordinates are along the bottom. If it is a line segment, you're going to write your domain as a compound inequality, all the numbers between 0 and 5. And if it's an open circle, you're not going to put the underline underneath it. If it's a filled in circle, you're going to put the underline underneath it. You will always put the smaller number on the left and the bigger number on the right. You will always use less than symbols. If you use any other symbol than that, you are asking to get it incorrect, unfortunately. Okay, let's Let's go over a couple more real-life examples. How can you tell if something is discrete or continuous, right? Here's some real-life examples, some more scenarios than just the ones that I threw out a minute ago. Things that would be discrete. Remember, discrete, no decimals. You can't have decimals or fractions, right? No decimals or fractions, not allowable. The number of children you babysit with how much money you make, right? So maybe you're a babysitter, you're going to do a comparison, how many kids I babysit and how much money I make in a certain night or evening or weekend. I cannot babysit half of a child or a third of a child or an eighth of a child, right? Impossible. The number of touchdowns a certain football team scores, right? Maybe we keep track of how many touchdowns they score with how many points they earned. You cannot score half of a touchdown, a third of a touchdown, 0.47 of a touchdown. Not going to work, right? Only whole numbers. The number of pages that you print off of a printer at maybe on your computer. I can't tell my computer to print 1.7 pages. That's not how it works. It's either going to print the whole page or it's not going to print anything. The number of tickets you buy to a concert, right? These are all situations where you cannot have a fractional amount. I can't order an eighth of a ticket, a third of a ticket, 7/8 of a ticket. It's not going to work that way. No decimals. These are all discrete. The number of children, number of touchdowns, the number of pages, the number of tickets. All those situations you could not have a decimal. Those are all going to be discrete. Over here in orange, my continuous examples. Now decimals are possible, right? The number of hours you work at your job. I could work at my job for a half of an hour, a third of an hour, 0.7 of an hour. That's possible. The number of seconds it takes you to run a race. Obviously, with a stopwatch, you can get decimals and fractions. Anything that usually involves time is most likely going to be continuous because we can measure time with fractions and decimals. The weight of apples that you buy at Aldi or Walmart or whatever Hy-Vee store that you go to, right? They have those little baskets where you can weigh it. The scales in the store so you can see, okay, if this costs $1.17 per pound and I have 3.5 pounds, how much am I going to pay, right? It is possible to weigh something and have the weight be a fraction or a decimal, 3.5 pounds, 1.7 ounces, whatever it might be. The number of candy bars that you eat, thinking about Halloween, right? Could I eat half of a candy bar? Sure. Could I eat a third of a candy bar? Yeah. Could I eat 0.87 of a candy bar? Yeah. And so real life examples, decimals are allowed when it's continuous. Decimals are not possible whenever it is discrete. Okay, just a couple more. I have 2 more boards and then we are going to be done. What you're going to see in some of the questions today is they'll give you an actual equation or they'll give you an actual input-output table and they'll ask you, hey, is this discrete or is this continuous? And maybe how do you know, right? And so here's an example. These are out of the book. This example right here, the equation is y equals 15.95x, and it represents the cost, y, so y stands for cost, the cost in dollars of x amount of tickets, x stands for tickets, for a museum. And it's going to ask you, is this discrete or is this continuous? Well, first they might ask you if this is linear or not, and it is linear because it's in the format y equals mx plus b. This is in the right format, so this is linear. But is it discrete or continuous? Can I have, look what the situation is. Look at what your input number is, right? This is your domain. The x is the domain, the input number. The number of tickets for a museum is what the letter x represents. Can I buy a fractional amount of tickets or a decimal amount of tickets? No, I cannot. So this is discrete. And in theory, how many tickets could I buy? What is actually the domain? Well, I don't know. The domain would be probably any number. Whoops, I have that wrong. We could buy however many tickets they have available, right? I guess we could sell them out. We're going to have any number greater than or equal to 0, right? Could I buy a negative amount of tickets? No, you can't buy negative tickets. But could I? Oh, no, that's not right because we can't have decimals, so I don't want to even write it like that. This would be any whole number, right? Any integer greater than 0. That would be my domain. Because in theory, you could buy 1 ticket, 2 tickets, 3 tickets, 4 tickets, 5 tickets, 20 tickets. You could sell them all out. If they had 100, you could buy all 100. We don't really know the limit, but we know that this would have to be whole numbers or integers, I guess. Integers 0 and above, right? We couldn't buy negative tickets. The second situation, m equals 50 minus 9d. This represents the amount m of money, okay, M stands for money, the amount of money in dollars you have left over after buying D DVDs. D DVDs. So could I go to a store? Well, first of all, this is linear because it's in the y equals mx plus b form. I don't see any square roots. I don't see any exponents. I don't see any variables in the denominator or anything crazy. This looks normal. Is this discrete or is this continuous? Look at what your input number is. Your input number is right here. Could I buy a fraction of a DVD? Could I go to Walmart or Amazon or the Redbox little kiosk out there by the movie theater? Could I buy a third of a DVD? No, you can't. This is another one that's discrete. Now this definitely has a limit though. This one doesn't go on to infinity and beyond, right? How many DVDs could I afford? Well, just look here. It looks like you have $50 to spend. And the D is being multiplied by this 9. Actually, it's being subtracted, kind of been multiplied by -9 if you want to think of it that way. I can't, looks like they cost $9 a piece, right? So if these DVDs cost $9 a piece, really how many can I afford? I could afford one. That would give me $41 left. So my domain would actually be, I could buy one DVD. That would cost $9. I could buy two. That would cost $18. I could buy 3 DVDs. I could buy 4. I could buy 5 DVDs, right? 9 times 5 would be 45. Could I buy 6 DVDs, though? If I put 6 right here, it's not going to work, is it? Because 9 times 6 is 54, and I can't have negative money. So your domain on this one is limited. You could only buy up to 5 DVDs. I guess you could buy 0. You could say, hey, I don't want to buy any DVDs. That would work. So your domain on this one would be 0, 1, 2, 3, 4, and 5, right? If I really had to be honest and be really specific. Okay, what about if it's a table? If it's a table, can you tell if it's discrete or continuous? Sure, just use your brain, use common sense. Look at the scenario. It's not going to be written as a sentence, it's just going to be written as a table. So here they're figuring out how many months is your input. That's where your domain's going to be. And then they're measuring the height of a plant in inches after so many months. So here's my question to you. Could we measure months with a decimal, right? Is it possible to have a half of a month or a third of a month or an eighth of a month or 0.5 of a month? Yeah, we could do that, right? So this is continuous. I forgot to say if this is linear or not. It looks like it is, right? This is following the same pattern, right? +1, here, +4, +4. So it grows 4 inches every 1 month. So this is linear. This is linear, it is continuous, and the domain would be however many months. When the domain is continuous, remember you have to kind of write it that weird way with the compound inequality. Could I have a negative month? No. So I would basically just start at 0 and get bigger. So my domain might be all the numbers that are greater than or equal to 0, right? There isn't really a number on the other side because you can't have negatives. There's no limit to how many months. I mean, in theory, we could measure this plant forever if it kept growing forever. So the domain on this one is all numbers greater than or equal to 0, right? Because we could measure it at 1 month. We could measure it at 1.5 months. We could measure it at 2 1/3 months. We could measure it at 7 months. We could measure it at 20 months if we really still had the plant alive, right? And then the last one on this board, this is the number of tickets that you buy and how much it costs. And so once again, we are asking ourselves, is this continuous or discrete? Look at what your domain is. Your domain is the x value. The number of tickets. Can the number of tickets be a decimal? No. So this is discrete. Now, it is linear though, because look, for every $10 or every 10 tickets you buy, the cost goes up $60. So it's obvious here that tickets cost $6 a piece, right? 10 times 6 is 60, 20 times 6 is 120, 30 times 6 is 180. So this is linear because it did have a consistent rate. It's $6 a piece, but it is discrete. And the domain on this, I really don't know how to write the domain. It would be I guess, it would be whole numbers. It would have to be whole numbers because remember, whole numbers start at 0 and then they get bigger and they don't have decimals. The domain would have to be all whole numbers from 0 and up because in theory, I guess we could buy all the tickets if we wanted, but we don't really have a limit on how many tickets we could buy. So that was discrete because the number of tickets cannot be a decimal. Okay, I'm at 14 minutes. I have one last board and then I promise I'm done. What about this one? Grand finale. The number of hours that you work with how much you got paid. First, is it linear or nonlinear? Some of you can tell really obviously, right? Some of you can just look and see, oh, I know what it's multiplying by right here, right? Super obvious. If you aren't careful though, I wanted to throw this in there as a trick question, because look, these are all different, but I skipped numbers, right? I went 2, 4, 5, 8. I didn't count by the same thing all the way. Don't let that throw you off, because look at this. Some people would see this and look, I have different numbers everywhere. That must mean something's wrong with this and it is nonlinear. Whoa, hold your horses, because look what I really have. In this first scenario, it went up 2 on the hours, it went up 12, right? The rate of change here is actually 12 over 2. In the second comparison I did, it went up 1 hour and we made $6, so 6 over 1. And then look at the last scenario. I purposely messed with this one and I made it kind of tricky on purpose. This one went up 18 and here we were counting by 3 hours. Look at our fractions. Would they all reduce to the same thing? 12 over 2, what does that equal? Obviously 6, right? 6 over 1 equals 6. 18 divided by 3 equals 6. So is this actually consistent? Yes. I just was tricky here and I counted 2, 4, 5, 8. I didn't count by the same amount every time. But if you're really paying attention, like most of you could have just seen it, I bet, hey, 2 times 6 equals 12, 4 times 6 equals 24, 5 times 6 equals 30, 8 times 6 equals 48. So is this linear? Yes, this is linear. It's the rate is $6, right? $6 per hour is your rate of change. That's actually your slope as well. We'll learn that later. Okay, now what it says on part B, describe the domain. The domain, is it discrete or continuous? Could I work for half of an hour? Could I work for an eighth of an hour? Could I work for a decimal amount of an hour? Yes. So this is definitely continuous. Continuous because you can work for a fractional part of an hour. And then how would I have to write the domain? I can't work negative hours. So this would just have to be, you could work all numbers greater than or equal to 0, right? Or maybe you could write it as all whole numbers. You could technically work any amount. Wait a second, not whole numbers. Whole numbers don't have decimals. I'm sorry. Don't listen to me. I'm getting confused. Just write it like this. It would be any number greater than or equal to 0, because you could work for no hours and not get paid at all, but you could do decimals and fractions. So that's why whole numbers was wrong. Whole numbers does not have decimals and fractions. Okay, I'm going to stop right there. I'm about at 15 minutes, I'm sure. I'm pausing. Oh, I'm at 17 minutes. So sorry. I'm going to stop rambling. I'm going to put some questions on Big Ideas Math. Feel free to ask me or Ms. Boseller if you have questions. See you guys.